Hey guys, and welcome to a new video in this C++ tutorial. In this video we're going to continue on object-oriented programming, and we're going to talk about inheritance and like what is inheritance and how we can use it in C++. So first of all, we're just going over here like a short recap of the last video where we talked about object-oriented programming in general and what it can be used for. So like, what is object-oriented programming? And it is about creating objects that can contain both data and functions, and then we can like work around with that in our program. So when we're working with object-oriented program, there are some different kind of advantages over like normal or like standard programming, which is like it is both like faster and easier to execute and develop when we're talking about object-oriented programming. And it also like provides a clear structure of the program, and we get a much better overview because we can divide our program into like smaller subclasses, and then we can like have different classes for like different kind of things in our program, and it just like creates a good structure for our program and gives a much better overview. And it also like helps us not repeating code, and it makes the code easier to maintain, modify, and debug. So we don't now, when we have created one class, like we don't like have to repeat code over again if we want to create another instance of that class. Then we can just create another object of that class, and it will contain the same data and have the same functions and stuff like that. So we can just like create one class, and we don't have to repeat code all the time. So it just makes it easier to maintain and modify and also debug, because we've just split them into like smaller classes. And it also makes it possible to create full reusable applications with less code and development time. So let's say we have created one class for one application, and then we want to like use the same class for another application. Then we can just reuse that class we've created for another application, and maybe modify some of the functions or data a bit. So it just makes it better to like have this portability and stuff like that, and in overall it just makes our program much better and a better structure at least. So in this video we're talking about inheritance and like what inheritance is in object-oriented programming. So inheritance is a mechanism where like one class, it can acquire the property of another class. So let's say like for example we have the example down here where we have an animal class here, and then that animal class could have some like property like functions, and also some data that we can like acquire to another class, like for example subclass. So this will be our superclass here, and then we're gonna have subclasses that are inheriting from our superclass, and then it will inherit the superclass data and methods if they're public or like protected. And we're going to talk about that as well later in the video. And inheritance also like makes it able to like reuse code. So if we have already implemented a class of an animal, for example, we have both like the name and the age and maybe a weight of an animal, and then we can just derive from that class, and then instead of writing the code again, we can just reuse that code from the animal class and inherit those properties of the superclass. So it just makes the code more structural again and save time. So it is like really good inside of object-oriented programming, and it's just like fit together. So the goal is to optimize the work done in inheritance, so it both like makes it more structural, and also like we don't have to type the data for every structure we have, or like any class we have. No, like let's say we have a lot of different kind of animals, like 100 and different animals, then it will take a lot of time to like write a member variables and member functions for all of those classes individual, where we could just have like one animal class, and then all the subclasses could inherit from that superclass and get the same properties as its superclass. So some different kind of examples here is that we could, for example, have a parent that is like that is the superclass, and then we have a child class that is inheriting from the parent. So the parent could have like a name and an age, and then the child could have like some attributes of like what parents or stuff like that. Or this animal example here that we talked about, so we're gonna have like one animal class that has like the name and the weight and like and the age of an animal, and then the dog could have like some other different kind of attributes that describes a dog, and a cat class could then have some other like member variable that is needed for describing a cat, and so on and so forth. And we can also like have like electric vehicles, so we can have different kind of types of electric vehicle where like they all need to have a number plate, and maybe some like what type of gas and stuff like that. And then we're gonna have like some superclass that is just called like electric vehicles, and then we're gonna have like a car and a truck and a bicycle and stuff like that. So we can have like different kind of smaller subclasses that is inheriting from that superclass of electric vehicles. So when we have inheritance in C++, like we can have different types of inheritance. Like we can have like, for example, here we can have like a single inheritance. So one class is just derived from another superclass, or we can have like multiple or multiple levels. So multiple will be like multiple, as we showed in the example with the animals. So like one superclass can be derived to smaller like multiple subclasses. And we can also have this multi-level here where we have like a base class here, and then another class is derived from the class A, and then we can also then have one more level and like an arbitrary number of levels, and then we can have like another class C here that is derived off a class B here. We can also like have some hierarchical or like hybrid virtual inheritance structures. So there's a lot of different kind of possibilities when we're talking about like inheritance and like how we can derive member functions and member variables from different types of classes. So it's just really useful to like know these different kind of stuff. And down here we have like the access modifiers to see like what is like known to us in different kind of situations where we use the access modifiers here. So let's say like we have the same class here, and they are public, then all like the members and the functions are known to each other. And also the same if we have like protected and the private here, because we're operating with the same class here, so we can always access the members and variables or like attributes of that class. Let's say we like then derive a class from a superclass, then we will derive the public and the protected member variables and functions like methods from that class. And if there were some attributes or methods that was declared like private in the base class here, then we wouldn't be able to like access those in the derived classes of A if it was declared private up here in the base case. And also like if we have outside classes that is not inheriting from another class, then we can only access the member functions like methods and attributes if they were declared public, and if they were declared protected or private, we would not be able to access those attributes and methods. So let's jump into Sublime text here and see some examples in code, like how we can use inheritance in C++. So we're now jumping into Sublime text here, and I'm going to show you the different kind of examples of like how we can use inheritance in C++. So first of all, we're just going to create a new class here, which is called a shape, and then we can have different kind of shapes that can inherit from this superclass here. So when we're talking about a shape here, like the shape, it could have like these two attributes here. So when we want that shape, we will give it the height and the width of that shape, and here just like to declare that it is a member of this shape class here. And we declare the access specifier here as protected, so we can access those attributes here from another like derived class. And also like the public methods here, where we have like an area and just an output shape here. So a function that just prints out a new shape when we call this function. And then first of all, when we're creating an instance of the shape here, like we can just set the attributes here to these input parameters here in the constructor of the shape class. But this is the superclass here that we're going to inherit from for different types of the shapes we want to implement. So the first subclass here we want to like inherit from the shape class here is a rectangle. So we have the rectangle here, and we inherit from the shape class. So a rectangle also has this attribute here, the height and the width. And then we don't have to specify or like initialize the height and the width here for a rectangle, because we're just inheriting those attributes from the shape class here. And we're also inheriting the area function here and the output shape function here. So first of all, when we're initializing a new rectangle object here, we give the two parameters here, the height and the width, and then we just like set those parameters or like input arguments here to those member variables that we have derived from the shape class or like the superclass. And then we have this area here where for like the different kind of types of shapes we want to calculate an area for that shape. And then we're inheriting like this function as well here, and then we can like override it down here in our rectangle class. So then we just return like the area of a rectangle, which is the height times the width. So this is the first shape, like type of shape we want to implement, and we can also like have another here down here. So this is like the multiple inheritance, where we have multiple derived classes from one superclass. In this case, is the shape class is the superclass, and this rectangle and triangle class is the subclass of the shape class. So with the triangle here, again, we use this public keyword here to declare that we are inheriting from this shape class here, and that this is the superclass, the shape class here. And then we have the constructor again, as in the rectangle, where we just give it the parameters with the height and the width, and then we have this function down here where we calculate the area, and the area of a triangle is the height times the width divided by 2, and then we just return that. So to see like how it works when we're creating objects of the classes here that we've created, then first of all we can create a rectangle class here, and we just have a name here for an object, and then we have this constructor here which takes like the height and the width of the rectangle, and then we can go down here and print it out, the area of the rectangle by accessing with the dot operator here, or with the arrow operator here when we're talking about the pointers that we've created, like the smart pointers we have created here. And we can see here that, well, if we just start with like initializing all our objects that we need to have to like run the program, we also have this triangle here which is initialized with the height of 5 and the width of 5, the height of 10. And then we create pointers, as we talked about with smart pointers as well, where we can create like smart pointers pointing to the objects that we create. So in this case here, we just have a unique pointer here, rect pointer, that is like pointing to a new rectangle object with these parameters here. So we have the height of 10 and the width of 2, and the same here with the triangle pointer, a unique pointer down here, which just like stores the triangle object here with the width, with the height of 2 and the width of 5. So now we've created those 4 objects here, 2 rectangles and 2 triangles. And then first of all, we can just access like the output shape here from the shape function. So this is from the rectangle class. The rectangle object here can access this output shape here from the shape class. So if we go up here, that like this is the only place where we define like the output shape here, and we can call this function here on the derived classes, because we have used inheritance, and we're inheriting this function here to the rectangle and also the triangle class as well. So when you call this rectangle output shape here, we will just like print out new shape, and then we can have like the area of the rectangle here, where we can access it from this object here and call the dot area. And for the pointer example here, we have this arrow operator to access the same area. And then we can do the same thing for a triangle here, where we get first the output shape, so we'll just print out a new shape, and we can again access the functions from the shape class, so the superclass, in the derived classes as well. And then we have this we call like the area from the triangle, and also the area from the pointed triangle. So if we hit Control B here, it will run the program, and we can see like what it does, and it will return the areas for us. So first of all, we're outputting the new shape here, which is the function from the superclass that we call on the objects from the derived class. And then we have this rectangle area here, which is 70. And in this case up here, we can see that 10 times 7 is 70, and the rectangle for the pointer here is 10 times 2, which is indeed also 20. And then we create a new shape here, where we have the triangle. We just call the function here again on the triangle object. And then we have the triangle area here, 25, and the rectangle area here of 5, or which should be triangle area down here. So it will print out the areas here, and we can see like how we can play around with inheritance in C++. So it can be used for a lot of different kind of things. If we have like multiple classes that needs to inherit from one superclass, so we have these attributes that are like that we should use for a lot of different kind of types, like for example animals, or in this case here we could have like also like a lot of more different kind of shapes. Like we can also have like circles and stuff like that, which will also like have some different kind of attributes which can be derived from a superclass. So that's it for this video, guys. Remember to hit the subscribe button and bell notification on the video, and also like this video if you like the content and you want more of it in the future. if you want to like do something with the things you learn here in C++ for some more practical examples, like I'm also doing computer vision tutorial in C++ with OpenCV and an algorithm and data structure tutorial in C++ as well. So if you're interested in one of those and you want to like try to use what you learn in this tutorial in C++ for something, you can go check one of the tutorials up here. I'll link to one of them here, or else I'll just see you in the next video, guys. Bye for now.